Welcome to this deep dive. Today, we're tackling a common tech headache, getting USB signals where they normally just can't reach.
Right. Standard USB cables, they just don't go very far. A few meters, maybe.
Exactly. But we're looking at a specific bit of kit today, the Kramer KDS-USB2-DEC. It's a USB 2.0 high-speed extension decoder. Sounds fancy.
It does. And our mission really is to figure out what this thing is and how it supposedly solves not just the distance problem, but also lets you use USB over networks.
Okay. And just so you know, our contest here comes mainly from product specs and info from HDTV Supply. They're a retailer, been around 24 years, good ratings. So let's start with the basics. Speed and distance. What are we talking about?
Well, first off, it's a decoder. So important note, you need the encoder part too, the KDS-USB2-EN. That's sold separately.
Right, need both halves. Got it.
And performance-wise, it's USB 2.0 high speed. So you're looking at throughput up to 480 megabits per second. Standard stuff there.
Okay, 480 megabits. But the distance, that's where it gets interesting, isn't it?
Oh, yeah. This is the first kind of jaw dropper. If you use standard solid core Cat5e or Cat 6 or 7 cable, you can push that signal up to 100 meters. That's 330 feet.
330 feet. That's already way beyond normal USB. But there's more, right? Fiber optics.
Exactly. If you switch to fiber optic cable, the distance just explodes. We're talking 10 kilometers.
10 kilometers. That's, what, over 6 miles? You could connect buildings across a campus easily?
Or, like you said, a server room to a remote office block miles away. It's serious range.
Okay, so massive range. What about actually plugging things in on the decoder end?
You get 4 standard USB Type A ports, and each one provides power to 5 volts, 500 milliamps.
So enough juice for typical peripherals, keyboards, mice, cameras, hard drives.
Yeah, cameras, keyboards, mice, external drives. Should handle most standard USB 2.0 devices just fine.
All right, so distance and basic connectivity, check. But you mentioned networks. That sounds more complex than just point-to-point.
It is. And this is where it gets really interesting, I think. It's not just about one encoder talking to one decoder. You can pair up to 7 of these decoders.
7!
7 decoders, all connecting back to a single encoder, which is connected to the host computer.
Whoa, okay, so let's unpack that. One computer, maybe in a server rack somewhere.
Right.
And then you could have users in 7 different locations, different rooms, different floors, maybe even different buildings if you're using fiber.
All interacting with that one host computer over the local network. Think collaboration rooms, control centers.
Real-time collaboration across a LAN. But wait, 7 users, potentially with multiple devices each, hitting one host computer's USB connection.
Yeah.
How does that not just, like, fall over? It sounds like an I/O nightmare.
That's the key challenge, right? Latency and contention. And that's where Kramer's proprietary tech comes in. It's called switchable USB.
Switchable USB. Okay, what does that do?
Think of it like a smart traffic cop for your USB devices. It enables these one-to-many setups, like one host to 7 users, or even many-to-many setups. It manages who gets control of which device when.
So it's not just extending the signal, it's actively managing the connections, like a virtual KVM switch, but for individual USB devices across a network.
Kind of, yeah. It lets you map and switch connections. So user A might be using the keyboard connected to decoder 1, then you can switch it so user B on decoder 2 has control, supposedly without lag or issues.
And how do you manage all that mapping and switching, especially with potentially 7 locations?
According to the specs, it's handled via Kramer's cloud-based control platform. That's where you'd configure which decoder talks to which encoder, which user gets which peripheral.
Okay, a cloud control layer. That makes sense for managing complexity.
Right.
Let's talk practicalities. Getting this integrated, is it difficult?
Seems designed to be pretty straightforward for professional installs. They call it true plug and play. No software drivers needed.
Nice. Operating systems.
Works with all the main ones, Windows, Mac OS, and Linux. It's OS agnostic.
And any compliance stuff for, like, government or corporate buyers?
Yeah, it's TAA compliant, so eligible for U.S. government projects. And it's passed USB-IF compliance tests, which basically means it should play nice with other standard USB gear.
Okay, sounds pretty robust. Now, the cost, what are we looking at?
The listed price for the decoder, just the KDS-USB2-DEC unit, is $440. That's marked down from an MSRP of $550.
$440, plus you need the encoder, right?
Right, need the encoder too. They do mention free shipping and a pretty long 7-year Kramer warranty. which is good. And there's a 10% discount code mentioned, 10% off.
Okay, so maybe around $400 for the decoder with the discount. Still, it's specialized hardware. You're buying into their switchable USB ecosystem and that cloud platform.
Exactly. It's an investment. But think about the capability connecting up to 30 USB devices in total, spread across those 7 decoders, all managed centrally.
30 devices. That's a lot of potential peripherals.
It is. And that actually brings up a final thought, sort of a provocative question maybe. If you have this system managing potentially, 30 devices across 7 locations, and some are high bandwidth, like streaming cameras, while others are low bandwidth, like mice, how does that cloud platform and the switchable USB tech ensure that switching a camera doesn't cause a tiny but critical lag for someone using a mouse or keyboard at the same time? How does it guarantee that seamless performance and reliability at scale with that mix of devices?
That's a really good point. Managing that complexity and potential for interference, especially in real-time critical applications, that's definitely something to consider.
Yeah. That's the deeper engineering challenge behind the impressive